Well, I'm here at St Philip's. Do you call it secondary?
St Philip's Christian College.
It's St Philip's Christian College with Dave Bonzo. And
Hello.
Dave's been doing some awesome work here with his students and incorporating 3D printing into the curriculum, even to the point where they're really inventing and creating unique and original objects and designs. So I just, Dave, you were telling me before about this solar car. It started off as a very simple kit.
Oh, okay. Well, we'll pull this one out. This is just one that I've grabbed. We started off with a basic solar car kit where you have 2 solar panels, a small motor, an axle, 4 wheels, and a sheet of core flute. I don't know if you can see that. That's not what this looks like. This was a modification. So the task for the students was to modify the solar car to add functionality and or aesthetics, mostly functionality, and to engineer that in. So this particular group here decided to add some tank tracks to make it sort of an all-purpose, all-terrain vehicle. These were 3D printed. Some of these were 3D designed, some of them were downloaded. They also put a shovel on the front. As you can tell, it's still in progress. Now the additional areas of functionality, this thing looks like brain surgery in here because they're still working on it. But you can see there's an antenna. I don't know if they can... Yeah. Okay, there's an antenna. And there's an Arduino processor, which is a small microcomputer up the back. All right. Apart from radio frequency coding from a transmitter into a receiver, of course that's got to be converted into a signal that will drive the motors. So there's a little bit of coding that goes on there, and in order to do some steering, they wanted to do some steering on this. Of course they had to do a differential drive because there's no way to go and move the tracks left to right. You just slow one down and you speed the other one up. So there's 2 motors on it, which gives it a little bit more grunt, which it needs. And the motor mounts didn't quite line up with where the sprockets and the gears were for the gear drive, the tread drive. So what they did was they had to go and print up some engine mounts using the 3D printer and made them custom, and they got them to fit just beautifully. Of course this thing runs solar, but it also has battery backup as well, just in case we had to test it on a cloudy day, which it ended up being a cloudy day when we actually did do some testing on them. Right. So that's one particular group, and it's a method of using 3D printing which I think really opens up the opportunities in a realistic fashion rather than just printing for printing's sake.
Yeah.
It's printing to accomplish a purpose,
yeah.
Which I'm always happy for my students to get somewhere better than where they were.
So here we've got a wide selection of very unique designs, and I'll let Dave explain how these have come about.
Okay, well I started with a project called the Photon Factor from Designability in Sydney. They provide a block of Jera and a strip of aluminium, and they also provide some LED strip, and the task for the students is to design a minimalistic lamp. In other words, very, very clean lines. They can shape this, they can shape that, and then they wire it up. The base project was basically to get a lamp working, a desk lamp. So some of them played around with the shape of the base. This one had actually 2 blocks of timber that are attached, and decided to have a dual lamp coming out, which presented a few little engineering problems in terms of circuitry. But that was the base project. The engineering part of it was to go and design a 3D printed component that would improve its function and or aesthetics.
Yeah.
So you have a range of different things from a speaker housing here. I don't know if you can see that.
Yep.
With a phone holder. Now the speakers actually plug into the bottom of the phone.
Oh, sweet.
This was actually quite a long build, and it was done in three sections and then attached. And the lamp actually works. I don't know if I've got it switched on at the moment, but it does work. There we go. So there it is.
Yep.
That was one project, all the way down to some components that would hold stationery and business cards.
Yeah.
In the work. This guy did 2 colors and shaped the timber. So these were all done on 3D printing.
And I spotted this one here, which I really like the look of.
Oh, that's my female. I've got a female doing engineering, and
there you go.
She is good.
Yeah, and I love the colours, because you know she's got the this pale
Polypropylene sheet.
yeah, this pale pink here, and that goes beautifully with the jarrah, and I just really like the shape she's arrived at there.
She was adamant that she wanted pink. In fact, we were going to do this whole block in pink.
Yep.
And we ran out of some filaments, so she ended up doing it in white and a little bit of purple. I don't know if you can see down the bottom's purple, but she used this polypropylene sheet, and we don't usually cover the lamp, the LEDs with it, but she wanted to do it to give a soft pink light. So you can see she's covered it, and it does give it a beautiful look, and it actually turns the white pink. The block of timber fits inside. Originally she was going to have a couple of holes for pencils here, but then realized that the neck would have protruded, and so that's just not happening at the moment.
And it just looks great as a pure design.
And then she's got a little track down the bottom where the wire comes out the back, so it doesn't sit on the bottom and rotate. So it's a little bit of stability, a little bit of aesthetics. So yeah, that's Jasmine.
That's a lovely design.
So there's some interesting ones. Difficult, challenging. In terms of getting symmetry.
And you were saying before that you don't pass any judgment on a design. You'll let the student try it out, and you won't be sort of like, no, well, that will never work.
To be honest with you, I am a skeptic. And I have to bite my tongue, because when I see some of the ideas, I think, oh my gosh, will this work? And you know, I have been proven wrong so many times by my students that I've learned to keep my mouth shut and have them give it a go, and if it doesn't work, we fix it. But they are more motivated than I am to see it succeed. So I would much rather support them in their designs than restrict them by my prejudices. As a teacher.
But even if it does fail, that's all part of the learning process. And you know, you were saying before that that some of the students wanted to put very tight turns in this aluminium extrusion. And so you accommodated them, and you tried it, and
we had a piece that we would test it out on, and I said, if you think that will work, try it on this piece of aluminium. They took it to the workshop and then creased it, and found out what happens when you crease aluminium. It loses all its strength. And it's very hard to uncrease.
Well, with an extrusion, almost impossible.
So what they did was a little bit of experimenting and testing, and they did sometimes that with the 3D prints as well. I don't know if I've got this. We've printed some prototypes of these. I don't see any out at the moment, but we printed them all about a third the size. Sometimes half to a third the size, just to have a look at it. And that was another beautiful thing you can do with 3D printing very quickly, and make a judgment as to whether you want it that shape or not, whether it's functional or not. So that's the lamp project. A little bit of engineering, a little bit of 3D printing. It all marries quite nicely together. And I'm really pleased with the results. They've done fantastic, and it just keeps getting better year by year.
And lastly, we might just have a look at some of the CO2 cars, the F1s. And are they both is this part of the STEM?
It's part of the iSTEM course.
Part of the iSTEM.
Now iSTEM, for those people that don't know what it stands for, it's really science, technology, engineering, and mechanics, or mathematics, which is STEM. But we couldn't call it that, because there already is a science course in Year 9 and 10. There already is a math course in Year 9 and 10. And the Board of Studies did not allow us to duplicate that. So the name of the course is Integrated Skills in Technology, Engineering, and Mechanics. Which by all of the names is STEM. So one of the projects that we do is the CO2 dragsters. All right, this is a basic balsa one.
Yep.
Very, very light and shaped. We do some aerodynamic testing by doing foam models
Yep.
and putting them through a wind tunnel and looking at the air patterns
Yep.
before we make them, form some judgments. But one of the fun things we do, since we had the 3D printer, was I gave them a chance to widen the parameters a bit and look at Formula One design. And I think I gave them about 40 parameters they could design within. Ranges of wheelbases and heights off the ground, etc. Within those parameters, they could come up with their own design. So they used a program called Autodesk Inventor.
Right.
And some of them used AutoCAD itself,
Yep.
which is free to schools now for 3 years.
Okay.
So it's a nice little tip. But this one in particular here, it was designed on Inventor, printed out. There's a little spot back here for the CO2 gas cartridge. Gets put on a race course. There's a couple of eye hooks down the bottom and a channel that's designed and purpose-built down the middle where we have a guide wire that actually holds it on the track, because to do these ones here do 10 meters in 1 second or less. The balsa ones do 20 meters in 1 second or less. That's the benchmark.
Yeah.
Balsa ones being a lot lighter.
And you've got timing gear to.
We've got timing gear that'll take it down to the 100th of a second.
Yeah.
Yeah. I think Scorpio Technology provides those. So, yeah. Fantastic. It's a good experimental use. Again, we do prototypes. With this one, since it's a CAD file, we can also run it through a program called Autodesk Flow, which will do computational fluid dynamics and give us a coefficient of drag as well.
Yeah.
So we look at the wind flow, we look at the drag. It's a very rich project. And then at the end, we do the racing, which is good fun.
Yeah.
And videotaping it in slow motion's always even funner.
Oh yeah.
More fun.
Especially if there's some crashes.
Oh, there's some crashes. There's always a few. We had some casualties, but no, it's a fantastic project, and they're a great piece. Okay.
And you were saying before, Dave, that it's lunchtime, and
Yep.
I might just pan around the room, and we can see how many lunchtime participants we've got in the lab, all working on various projects, and some of them personal projects, aren't they? Or are they mostly to do with the curriculum and?
Some of them are not assessments. They're extension work that they're working on.
Oh, okay.
Yeah. So there's some robotics happening up the back. That's extension work that they're working on with robotic arms and timing and sensors. Gosh, quite challenging task, but they seem to be mastering it.
Yeah.
There's others that are working on assessment tasks. There's some other ones just around here who are working on some electronics kits. They've found that they really like electronics.
Yeah, I was just talking to them about it, and they're doing the Dalek voice module.
Yes, we're gonna have some Daleks here. So we'll plug it into the classroom speakers and see how it sounds. Hopefully it'll be working. A fair bit of learning of components and how they get put together with printed circuit boards, but all good fun.
Yeah.
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 Which is what learning should be. I think we forgot about that in school, that learning should be fun.
Yeah.
It
Yeah.
should be an enjoyable thing.